Okay, folks, we're going to talk. This section is section 1 of chapter 5 on exploring angle pairs. So, we talked about angles and how to name angles in the last section. And this section, we're going to talk about the different relationships that angles have to one another. Okay. So, today you'll be able to comprehend and demonstrate the difference between each of the angle relationships. All right. The first angle relationship we're going to talk about is probably one of the most important in geometry, and that is vertical angles. Okay. So, vertical angles. By definition, when angles are vertical, it's two angles whose sides form pairs of opposite rays. Okay, that's the book definition. Okay, that may not make a whole lot of sense right now, so let me put it in layman's terms. All right, if you look at the diagram here, do you see angle 1 and angle 3? They're vertical, and they also have equal measures. Now, if you look at 2 and 4, that means they're vertical, and they have equal measures. If I look down here, let's say that this angle by chance has a measure of 60 degrees. That means its vertical angle over here is also going to have a measure of 60 degrees. On that same note, if this angle up here is 120 degrees, this angle down here will also be 120 degrees. Now, this red angle here at 60 and 100 and this blue angle 120 also have a different relationship. We'll talk about that here in just a moment. All right. So vertical angles are very vital to geometry. You're going to be seeing that a lot throughout this year and even in future math classes beyond this. All right. So a moment ago, let's review. We talked about vertical angles, angles 1 and 3. They have equal measure. And also 2 and 4, they have equal measures. Now, the next relationship we're going to talk about is adjacent. Now, you may know the word adjacent means next to. So, adjacent is next to or neighbor. So, if you look at the following, I'm going to highlight this angle right here. Just by the way, in yellow, that is angle KNL. And then the blue, that is angle MNL. I want you to notice a couple things. First of all, they both have a common vertex point. That's the point N. You see right here, the common vertex point N. They also share a common ray. The common ray that they share is ray NL. Because they share a common vertex point and a common ray, that makes them adjacent. And notice also the yellow angle and the blue angle are not inside either one. So that means that they're both next to each other. They share a common vertex point and they share a common side. That common side is side NL. And I'm going to highlight that in green because that's what you see right there. All right. That's adjacent angles. Next, we're going to talk about complementary angles. Now, when two angles are complementary, that means that their measures add up to 90 degrees. In other words, they form a right angle. So, if you look right here, both of these angles are going to form a right angle. Now, let me show you something real quick. Let's say this angle up here is 37 degrees, and I want to find its complement. We'll call the complement x. That means that x plus 37 equals 90. Well, since x plus 37 equals 90, to determine the value of x, I just subtract 90 minus 37, and that's going to make x equal to 53 degrees. Now, as I told you earlier, on notes, and if we were doing homework papers, you'd want to put the degree symbol. But on Canvas, don't try to type the symbol in. Just type in the number. And the same thing goes here. Let's say, I'm just going to throw out another number. Let's say that this angle here has a measure of 66 degrees, and we're going to call that y. I'm just giving you a number or a variable that I don't know. So that's going to be y plus 66 equals 90. So then y equals 90 minus 66. So that means that y equals 24. Okay, so that's that. Now, in some cases, I'm not saying all cases, but in some cases, you may be given something like the following. Like down here, let's say this angle is x, and let's say this is 2x. Angles with a measure of x and 2x are complementary. That means that they add up to 90. So that means that x plus 2x equals 90. Well, when you add x and 2x, remember, that's 1x plus 2x equals 90. You learned that x and 1x are the same. You learned that that is the identity property of multiplication, and you learned that in algebra. You may not remember it, but you learned it in algebra. So 1x and 2x is 3x equals 90, so therefore x equals 90 divided by 3, which means that x equals 30. All right, now that's our x value. X value is 30. But it wants to know the measures of angles x and 2x. Well, x equals 30, and then 2x equals 2 times 30, which is 60. So we got 30, and we got 60. There you go. Those are your numbers. All right. Okay. We're doing good so far. And I'm doing good on time too. So now that was complementary angles. Supplementary angles work very similar, but they add up to 180 degrees. So complementary adds up to 90, supplementary adds up to 180 degrees. So let's say that this angle right here, I'm going to call it, so let's call this one y. And let's say that this angle is 130 degrees. Well, what's its supplement? Here's what we do. Y plus 130 equals 180. So y equals 180 minus 130. So therefore y equals 50 degrees. All right. Now I want to show you something right here. These two angles are supplementary. They're not adjacent to each other because they don't share a common endpoint or a common ray, but they are supplementary to one another. But in this case, we say that this angle right here, we'll say that this one is x and that that one is 5x. Okay, I did a example like this in class with you not too long ago. Does this look bigger than that? The answer is no. What do we trust? Do we trust the data or do we trust the diagram? The answer is you always trust the data. The diagram's there to help you, but you always trust the data. All right, so now I have x plus 5x equals 180. And remember, that is 1x plus 5x equals 180. So therefore 6x equals 180. Therefore x equals 30. So x equals 30. Now, the first component is just simply x, so x is 30. But the other component is 5 times 30, which equals 150 degrees. And if you check that, 150 plus 30 does equal 180 degrees. All right. Now here's another term that I want to go over with you right now. That's called a linear pair. Now a linear pair is right here. They are both adjacent. The two angles are both supplementary and adjacent. This is an example of a linear pair, just like this one up here. This one too that I'm pointing to now is not a linear pair because they're not adjacent. These are, they share the common ray, and the common ray here is, ray GH. All right, that's a linear pair. Okay. Now, I'm going to work some examples with you. I'm going to see how well time goes, and then if we run short on time, then we'll go into the next video. All right. Now, perpendicular lines form right angles. Okay, if two lines are perpendicular, that means that they form a right angle. They do cross and form a right angle. And the symbol for perpendicular is this right here. It's an upside down T. That's the symbol for perpendicular. You'll be seeing that a lot in this class, so get used to it. All right. Now, each of these has a different set of circumstances. So if the measure of angle EDG, that's this angle right here. If I look at that angle right there, let's say it's 43 degrees. And I want to determine the measure of angle FDG, which I'm going to say is right there, and we'll call that X. Now, here's what we know. We look at them, and we know that they're complementary. So X plus 43 equals 90. So therefore, X equals 90 minus 43, which is 47. So that's 47 degrees. All right. And I'm going to go ahead and pause this for a moment, and I'll come back with part 2, and we'll talk about some more.